been talking about three-dimensional figures this unit so far, and the last two lessons were about volume, which was the space inside of a three-dimensional figure. For the next couple days, we're going to be talking about surface area. So surface area is how much area is on each surface of a three-dimensional shape. So here's a rectangular prism, also a cube, just because these happen to be the same shape. And so I want to know how much area is on this face, how much is on this face, how much is on this face. And we're going to look at different formulas for that. So we've got rectangular prisms. We've got triangular prisms. So the bases match. I tried to color code them so you could see it. The bases match, and then the other faces are rectangles. And then we have cylinders. So pretend that this was solid right here and not like the ribbon. This would be a cylinder. So we'll look at that too. It's formula heavy, but if you can kind of visualize what the shapes, what the faces of the shapes are looking like, that's going to be really helpful. So the notes that you need are the next one in your packet. It doesn't really have a title on the top, but it looks like, let's see, I'll reconnect here. Looks like that. So find that page. The biggest thing I've noticed with the homework that you guys have been turning in the work that I've seen is just organization of the work. So I would say 90% of you did a great job on the last test, just keeping your work organized, and I could follow it. A lot of you wrote the formulas down and then filled in the parts that you knew. And I recommend that you keep doing that, because this surface area gets a little bit bigger in terms of what the formula entails, and it's going to be really helpful if you have a good organizational tool. So the way I model the problems is how I recommend you doing them yourself. And as you get more comfortable, you can totally kind of branch out and try it in a slightly different way. There are different ways to find surface area. I'm just going with the way that I think works really well. And again, the organizational method that I also think works really well. So I recommend that you do that. It's the people that don't show the work, or their paper, your work's all like scratchy chicken scratch all over the sheet, that I have a really hard time grading and following and checking to see if you actually understand the topic. So we're going to start with rectangular prisms. Rectangular prisms have, pretend this isn't a cube, pretend this is a rectangle. The two of the bases on the top would match, the two bases on the right and the left would match, and the two bases in the front and the back would match. A better example would be this box right here. These small rectangles match, these side rectangles match, and then the front and the bottom match. So there's three different pairs of sides. So there's the two sides, there's the front and the back, and then there's the top and the bottom. So if you look at the formula off to the left, it takes that into account. The surface area says, find two of the lengths and the widths. So find, this is the top and the bottom. Then it says find two lengths and heights, which would either be like the right and the left or the front and the back. And then it says find the two widths and the heights, which would either be the front and the back or the right and the left. Sorry, my cat really wants to say hi. This is Kailan. She's from China, Guangzhou, China. And I got her as a kitten, and we named her Kailan because we have Dora the Explorer cartoon, and in China they have Ni Hao Kailan. So I named her Ni Hao Kailan, so when I go home, I can say hi to her. Okay, so you might hear her in the background. She's just being kind of needy right now, and I apologize for that. Okay, so it doesn't matter what order you find the different dimensions in, but you can't like repeat it. So what I mean is, in number one, I'm going to do 12 times 7, and then I'm going to do 7 times 9, and then I'm going to do 9 times 12. If you end up with the same multiplication twice, you've repeated a pair of sides. And I hope that will become evident the longer that we do this. You'll be like, oh, I just did the same thing twice. Okay, so one thing I recommend, because this unit is so formula heavy, that you identify the shape and you write down the formula that you're going to use. And then you just plug stuff in that you know belongs to that formula. That's the easiest way to do these. So number one is a rectangular prism. And the formula for surface area is 2 lengths and widths plus 2 lengths and heights plus 2 widths and heights. So again, I'm taking into account 2 lengths and widths, 2 widths and heights, 2 lengths and widths and heights. I think I said the same thing twice. Okay, so now I'm gonna look at this. I'm gonna label my figure just like we did before. We labeled base, we labeled height, we labeled the height of the prism. So in this rectangular prism, I'm gonna call the 12 my length, I'm gonna call the 7 my width, and the 9 makes sense to be my height. And now I'm just gonna plug stuff in. So I get 2 times 12 times 7. So I'm finding the top and the bottom, the areas of the tops and the bottom. Then I'm going to add to that 2 lengths times height. So that's one of the sides. So 12 times 9. So that's either the right and the left or the front and the back. We don't know yet. It depends on how you see it. And then lastly, I'm going to do 2 times the width, which is 7, times the height, which is 9. So again, I either did the front and the back, or I did the right and the left. Cool. Now I'm going to do the multiplication. If you're not sure what it is, use a calculator. That's fine. Just be careful what you type in. And again, this right here, let me change that color. This right here is awesome because I can see exactly what you need to know, that you knew what all the different dimensions were and you plugged them into the right formula. Okay, so this becomes 2 times 12 times 7 is 168. 2 times 12 times 9 is 216. And 9 times 7 is 63. 63 times 2 is 126. Okay, now I just add them together for a grand total of 510. And its area, even though it's a three-dimensional shape, it's still area. So I'm going to put centimeters squared. Okay, so again, the key is organization and labeling. All right, let's try another one. Let's do number 3. So I'm going to start off with the formula. It's a rectangular prism. So I get surface area equals 2 lengths and widths plus 2 lengths and heights plus 2 widths and heights. Okay, now I label the parts. I'm going to call the 4 the length. I'm going to call the 6.5 the width, and the 11 is the height. Okay, so now I plug it in, length and width. I'm going to do 2 times 4 times 6.5. So I found the top and the bottom there. And then I'm going to do 2 times 4 times 11. So I either found the right and the left or the front and the back. And then I'm going to do 2 times, sorry about that, the 6.5 times the height, which is 11. And again, because we're doing all different parts of the prism, none of those should be the same. Okay, cool. So let's do the math, type it into the calculator. The first one's 52. Whoa, that's not a good 52. Sorry about that. I'll rewrite my 5. 52 plus 2 times 4 is 8. 8 times 11 is 88. Plus 2 times 11 is 22. And 22 times 6.5 is 143. Don't worry, I didn't do that one in my head. I've got a little cheat sheet that I'm looking at. I would have probably typed some of those into the calculator, but I do try to do the mental math ones that I know I can. Okay, so I get 283 meters squared. And the cat just undid some stuff. So 283 meters squared. Okay, seriously, she walked on it and it did the undo button because her feet are warm, right? Okay. All right. So hopefully you're feeling pretty confident with that. If not, I'm going to help you guys label stuff and get you really sorted out if you do need help, okay? I think the triangular prisms are the hardest, and it's really hard to visualize what it is that you're finding. I've got these toys of Penelope's right here, and basically a triangular prism has a top and a bottom that are triangles. So we need to find the area of a triangle, right? Those are the bases. So notice in the formula, it says 2 times capital B, and capital B is the area of the base. So we're going to find the area of this base and then the area of this base, and we're going to multiply it by 2. Now, what's interesting about a rectangular prism is if you take the bases off and you open it up, you get a rectangle like this. Okay, so this is what the sides of a triangular prism look like. So what we need to do though, is this is basically just going to be length times width, right? But if we fold it back up, you notice that the thing that made up the length is actually the perimeter of the triangle. So if we took the triangle and added up all 3 sides, that gives us the length of the rectangle that makes up the side. Then we have to multiply it by how tall it is, which is the height of the prism. Okay, and I know that's so hard to figure out, so don't feel bad if you can't visualize that. Maybe we can find other things to figure it out. But basically, I need to find what's called the lateral area. This is the lateral area because it's the area of the sides. Your lats, right, are your sides. So I'm going to find the lateral area by finding the perimeter of the base, which is the triangle that fits right here, and then multiplying it by how tall the prism is. And that gives me the area, of this rectangle. Okay, so that's what this LA off to the side means. This LA is saying find the height and multiply it by the perimeter. That gives us this piece right here. Then to find the surface area, we take that answer and we add it to these two bases. So we've got base 1 and then we've got base 2. Okay. So hopefully that kind of makes sense. I'll keep talking about it. And again, I'm happy to show that to you as best I can when we meet during class. Okay, so the first thing I'm going to do is I'm going to identify the shape. These are triangular prisms. Sorry, I think I said a rectangular prism earlier. And I like to outline the triangle. So here's the base right here of this number 4. Okay, there's my triangle. There's my height of the triangle, which is the 2.7. Okay, so I know that if I like to redraw it sometimes, here's what the base looks like. Okay, looks like that. Hopefully you can see that. Okay, the bottom side is a 10. The right side is kind of hard to see, but this right side right here matches up with this right side up here, which is 3. And this back side here matches up with this back side on the top, which is 9. So I think it's really helpful to redraw it sometimes to get a better picture of what's happening. Again, if you don't have to, you don't need to. It's just a kind of a cool trick you could do. Okay, so I'm going to first find the lateral area. The lateral area is the perimeter times the height. So the perimeter of this triangle is 9, sorry about that, 9 plus 3 plus 10. So it's going to be 9 plus the 3 plus the 10. Oops, that's a 10. Okay, 9 plus 3 plus 10. Yep, got it. Times the space between the two bases. And if you look at the figure over here, the space between the two bases is this 4 right here. Okay, so you got a triangular base at the top, a triangular base at the bottom, and that 4 is in the middle. So I'm going to put a 4 in here. Okay, so I'm going to parentheses, order of operations, 9 plus 3 is 12, 12 plus 10 is 22, and I get 22 times 4, which gives me 88. Okay, I'm not done because what I just found was this. Okay, I just found the area of this part. I opened it up, I found the perimeter of the base, and I multiplied it by the height. So here's the perimeter, here's the height. Okay, and I got 88. Now I've got to add to that 2 of the bases. So I'm now going to find the area of the base, which is, here's my triangle right here. And area of a triangle is base times height divided by 2. So I get my base is 10, base times height divided by 2. My base is 10, my height is 2.7, and actually I'm going to do times 1/2 because I think that's what we talked about in class. So 1/2 times 10 times 2.7. And there's 2 of them. So I'm going to do times 2. So guess what? What is 1/2 of 2? 1. So guess what? This 1/2 and this 2 are going to cancel each other out because half of 2 is 1, and 1 times this is still 10 times 2.7. So what is 10 times 2.7? 27. So guess what? The surface area for this triangular prism is 88 for the lateral area plus 27 for the two bases, which is, I'm sorry, I'm running out of room here, 115 inches squared. Okay, I'm not super impressed with how I did that problem because I kind of had it all split up a little bit. So I'm going to try it one more time with a little bit more organization, and then we can work on that too, because I apologize for that. Okay, so we're going to look at number 5. Number 5 is a rectangular prism, a triangular prism. I'm going to find the perimeter. I need to find the lateral area first, which is the perimeter times the height. So my perimeter, let's get rid of this little 2 there that doesn't really want to fit. Okay, my perimeter is, so here's my base right here. This triangle is my base. I've got 8, I've got 15, and then do you guys know what this is here? What's the hypotenuse? What's the length of the hypotenuse? It's in the figure. You don't have to do the Pythagorean theorem. Do you see it? Yeah, it's 17. It matches the other side that's over there. Okay, so my perimeter is 15 plus 8 plus 17. Okay, so 8 plus 15 is 23. 23 plus 17 is 40. So my perimeter is 40. Now what I'm going to do is I'm going to find the lateral area. And the lateral area is the perimeter that we just found times the height. The space between the 2 triangles is 21. So I'm going to do 40 times 21, which gives me 840. Okay, so there's my lateral area. Now, this is me working on a better organizational pattern here. Okay, now I've got to find the area of the 2 bases. So one base is 1/2 times the base times the height. Remember, the base and the height form the 90-degree angle. So do you see the 90-degree angle in the figure? The 90-degree angle is right here. So that means 8 is the base and 15 is the height. Okay, so I'm going to go back here. So I get 8 is the base and 15 is the height. Okay, half of 8 is 4. 4 times 15 is 60. So the area of my base is 60. Okay, I like this organization better. Now what I'm going to do is I'm going to plug it into the formula. So surface area equals the lateral area, which I found right here, 840, plus 2 of the bases, so 2 times 60. Okay, I like that better. We know how to find area of a rectangle, which was the lateral area, and we know how to find area of the triangle, and now we're just plugging them into the formula. So 840 plus 2 times 60, which is 120, gives me a grand total of 960 yards squared. Okay, so I apologize, there's not a lot of space to do the work in this. I think if I had time to rewrite it before I sent it out to you on March 13th, I would have given it a little bit more room. Okay, so what I'd like you to do right now is we're going to do the on your own in the lesson, okay, before we go to cylinders. So I want you to hit pause in just a second, and I want you to try to find the surface area for number 6, okay? So use number 5 as an example because the work was worked out a little bit better. So take a minute, hit pause, find the surface area for number 6. Then I'm going to walk you through the answer, and then we'll do the last thing, which is cylinders, and then we'll talk about it a little bit more in class. Just so you know, this is probably the hardest lesson of the entire unit. So try not to freak out. There's a lot going on, but it's going to be okay. We'll spend a lot of time on it, and we'll just keep working on it, okay? Okay, so hit pause. I'll see you in a minute. Hey, welcome back. I hope you got an answer of 529.2 meters squared. Okay, if you didn't get that, don't worry. Again, we're going to work on it in class. So let's start with the perimeter. So remember, we want to find the distance around the base. So we've got one side down here is 9, another side over here is 9, and this third side over here is 9. So the perimeter, 9 times 3 is 27. Okay, do you guys know what kind of a triangle that is? Yeah, equilateral triangle. Nice. Now we're going to find the lateral area, which is the perimeter, times the height between the 2 bases. So if you look up here, here's the height between the 2 bases. Okay, so I'm going to multiply that by 17. So the lateral area, that rectangle on the sides of those 2 triangular bases, ends up being 459. Okay. So now we have to find the area of each triangular base and multiply it by 2 because there's 2 of them. So area of the base is 1/2 times, the base down here is 9, so 1/2 times 9, and the height of the triangle over here, remember it makes the 90-degree angle, is 7.8. So it's 1/2 times 9 times 7.8. And if I do the math on that, sorry, I get 35.1. Okay, now I'm gonna find the total area, surface area, which is the area of the sides, 459, plus the 2 bases, so 2 times 35.1. So that's 70.2. 70.2 plus 459 is 529.2. Okay, again, don't get discouraged if you're like, what just happened? There's plenty of time for us to work this out. Remember, there's office hours, and I'll tell you how we're gonna do it together if you need to. Okay, the last example that we're gonna do is a cylinder. So a cylinder, same thing. It's got a circle on the top, a circle on the bottom, and the sides, what's interesting about the sides, sorry, I don't have these magnet things, is if you cut like the label off of a soup can and unroll it, a soup can's round, right? But if you cut the label off and unroll it, it's actually a rectangle, which is kind of cool. And its dimensions have to do with the circles, like all going back to the radius of a circle. Okay, so we're gonna do 2 parts. We're going to find the lateral area and the surface area, but actually, let's not even think about the lateral area as a separate thing, because if you look right here, the lateral area is in the formula. So because it's all like split up into little parts, we don't even have to worry about doing it separately. So here's what I would do. Let's look at number 9. Okay, so if I wanted to package something and figure out how much material I need, this is a lot of stuff that people do in like engineering and marketing and things like that to figure out cost analysis, is they're finding surface area of stuff. So surface area is, I'm going to write out the formula, 2 pi r squared. Do you know what that represents? Well, pi r squared is the area of a circle, and 2 pi r squared means the 2 areas of the circle. So that part of the formula gives us the area of the top, and it gives us the area of the bottom. The second part of the formula is 2 pi r h. Well, 2 pi r is circumference, so it's the circumference times the height. So that's giving us that side area. Okay, so what I'm going to do is make sure that what they're giving me in the problem is the radius. Okay, remember, because sometimes you have to cut it in half, right? So 6 is the radius, perfect. So now I just plug stuff in. So I'm going to do 2 times 3.14 times 6 squared plus 2 times 3.14 times 6 times the height. And remember, the height is the space between the 2 circles, and that is 21. It's the only other number in the problem. Okay, I've got to be really careful to do order of operations. So I'm going to do the squared first. So exponents happen first. Okay, so I'm going to do 2 times 3.14 at the same time. So I get 6.28 times 36 plus, I'm going to do this as 6.28 again. 6.28 times 6 times 21. Okay, just so you guys know, there's probably like 10 different ways to simplify this. Once you have it written in this entire formula, you can simplify it a bunch of different ways and still get the right answer. So I'm just doing it in a way that makes sense to my brain. If you just want to do the 6 squared and then everything else, that's fine. But be careful, because you have to do multiplication before you do addition. So I have to finish figuring out what this is and what this is before I add. So because you probably don't have that good of a calculator, like I brought mine home, right? And if we had these in class, way easier. But what I would do is I'd probably do the 6.28 times 36 and write what I get, 226.08. Don't round to the nearest tenth until the last step, okay? So leave it like that. Then I'm going to type this other side into the calculator and see what I get. So 6.28 times 6 times 21, I get 791.28. Okay, now I'm going to add. So 226.08, and now I'm going to round too. I get 1017.4, this is area, centimeters squared. Okay, so I kind of like cylinders. Those are like the nicest ones to do. Just because you can plug all the numbers in and you don't have to worry about finding different parts. Okay, so what I would like you to do is hit pause again, and you're gonna do number 10 as an on your own. So ask yourself, are they giving you the radius? And then what's the height, okay? And in number 10, they're looking at the cylinder like this. So this is not the height. Remember, the height is the space between the two circles. Okay, so hit pause. I'll give you the answer in just a second, and I'll see you in a sec. Hey, welcome back. So hopefully you got 1,481.3 meters squared. Okay, I don't want to spend the time going over it because I do want to talk about it in class. Also in class, we're going to probably look at either number 7 or 8. So if you want to get a jump start on those, you can. Not required, but one of those will probably be a warm-up question, and that will help decide where you spend the rest of the class, either in a breakout room or getting extra help if you're not able to get one of those. So good job. Don't freak out. This is hard, especially the triangular prisms. So just take a deep breath. We'll get through it, and it won't be the last time that you see it.